Hello everyone and welcome to another development update for Shadow Heroes Vengeance in Flames, where you get behind the scenes access to all the things we're currently working on the game. So yesterday we worked on getting the status effects system up and running. We had the equipment system in where it's changing your unit stats as well, but it's separate from status effects because there's a couple of unique little scenarios that we need to account for it. So for the status effects talk, it's going to be mostly programming based. I'm going to run over some of the ideas behind the data structure, but I'm going to keep it as simple as possible. The only things that I'm really going to be talking about without explaining what they are is what an array is and what a pointer is. But other than that, it's pretty straightforward. And just to explain it right now, in case anybody who is starting out in programming, they don't necessarily know what those things are. A pointer is basically an object or a thing that says "look here." So it says, if you're looking at this memory address, you're actually going to point to this object here. So it says, look at this object. And you can change them sometimes and have them look at different things if you really want to. But basically it's just saying, look at that thing over there. It's a really efficient way of taking small amounts of memory and pointing them at different objects so they're not being used over and over and over again. And then an array is basically, think of it as a list of things. So you can have 3, 4, 5, 6, 7, 8 things in an array. It doesn't really matter. It's just a container that groups them together. So that's basically it. So that's the simple things. But the entire data structure for our status effects had a couple of goals in mind. The first one was that it had to be as self-contained as possible. So we didn't want to have the code for this across multiple files all over the place. We wanted it in essentially one spot for it to do all kinds of different things. And we also wanted it to self-manage. We didn't want to have a giant pool of every different unit's status effects everywhere. So that's not something we wanted. What we did want to do was have it so it would take care of itself. We didn't want to have all kinds of different things. So those are two of the goals that we had in mind. And the third one, obviously, that had to be some kind of way of being able to modify easily, and hopefully we accomplished that. So I'm going to jump right into it, and here is our data structure, kind of. So this is very simple outline of what it is. Not everything is actually inside of here. It's just kind of like the .h overview. And I'm going to explain what this is. So this is our status effect file. And the very first thing is the affected actor. So this is going to point to whatever unit on the, right now it's set to null, but that's just because it's using terminology that, because we're using a engine with Epic, that we can't actually disclose what this is, just out of non-disclosures agreements and stuff like that. But this is essentially going to point to our individual unit that's on the screen. Right, so it's the guy running around. That's who it's going to point to. It's actually going to point to his AI controller, but it's going to go right here. Because for us, we put all of the stats and everything inside the AI controller. That's why we're pointing it here. Otherwise, it could have pointed to the actual unit. If you set it up that way and that's where their stats are, then that's probably the better way of doing it. The next is a modification list. So this is the array, and the array is going to be able to grow or shrink. So it's closer to a vector, but basically inside of Unreal, you can have arrays that grow that aren't much of a problem at all. So you can have either none or as many of these as you want. And what they're holding is a structure. So the structure is just got two variables inside of it. It's just contained. It has a status name, and this is an enumerated value. So this is max HP right now, but it could have defense or basically any stat in the game, movement speed, range, your attack speed multiplier, all kinds of stuff. You basically choose it from anything inside inside of the enumeration, and if we want to add different status effects later that affect different things, we just add them to enumeration, and this will populate automatically. And then we have modification. So this is going to be how much you're going to modify that stat. So 0 by default, but you could give it plus 30 health or plus 10, negative 20, it doesn't really matter. This is going to work for anything. So you can put as many of these in as you want. So I could have 15 different modifications on a single buff. So I could buff every single stat by 10 if I really wanted to. I could list it 2 or 3 times if I wanted to, so I could list max HP like 7 times and it'll add them all up together. And it works. It's really hard to break this part. As long as even if it's null, it doesn't matter. So it's always going to be inside there. So duration, how long the status effect lasts. And right now, if you put a duration of anything less than 0, then it will last forever. Your effect icon, null. This is just going to be a picture. It's not actually implemented yet, so I don't know what I'm going to put there. But it's just going to be the icon that's going to show up. I don't have any icons yet. The effect type, right now, this is going to be a numerator value as well. It's either a debuff or a buff. Now, this is used specifically because we have our unit, the Exorcist, which removes buffs. And we don't want him removing debuffs that your team put on the enemy units. And they're going to go inside of the same kind of status effect queue. So what he does is he looks at the first item and says, is this a... well, I'm going to go over it here and remove effect. So we'll get to that later. But this is going to be either buff or debuff. So that's it for the variables. Inside of the functions down here, we have one private function, and that's timeout effect. We don't want anything to actually remove the effect itself, because what happens is as soon as you set the affected actor down here, the public effect, it sets up a timer for your duration. And if that timer is higher than 1 or higher than 0, then it'll time out after that many seconds. So if it's 6, after 6 seconds, it will time out, and it'll basically clear its own timer and remove itself. But that's what timeout effect does. So when it's removing itself, it has to deal with a couple of different scenarios. So it all kind of comes down to something more like this. I'm going to slide this guy over here just for a second. Let's grab our rectangle. So you're going to have something set up like this. You should have a box. Okay. So consider this a status effect. Right? You could have a bunch of them inside of a queue. Something like this. Right? So basically each one has these protected values here. So each one has a previous. So this guy has no previous, but he would have a next. So he's kind of connected. Like, let's go like this. So he kind of goes like this. That's very horrible. Let's try again. Let's just do straight lines. Not the artistic thing to do, right? So these guys are kind of going like this. And this one doesn't have a next, and this one doesn't have a previous. So this is how it kind of hooks up together whenever you add a different status effect. Now, when an effect times out, you have to account for all the different scenarios inside of here. So you have to account for if this guy, this one here, if it times out, you have to check to see, okay, does it have a next? Yes, it does. Make my nexts previous, so this connector here, it's going to connect to here. So my nexts previous is going to connect to my previous. And then my previous, do I have one? Yes, I do. Connect it, connect my previous next to my next. Right, so you're going to get something like this. And that's if you remove this guy. And that's the most complicated of all of them. So that's really easy. If this guy's removed, it's super easy. Okay, what happens here? If this guy gets removed, well, I don't have a next, so I don't need to worry about it. But I do have a previous. So to prevent the hanging pointer, and because we're checking against null inside of the CPP files, just make sure that it's next. So my previous is next is null. So it's essentially just erasing this part right here. So that's kind of the idea behind it. Right, and then if the first one is removed, it's again very simple. Let's connect it back. If our first one is removed, it's all kind of connected to an outer structure, which is like your character. So he's going to have his own pointer here that kind of points to the very first one. So this is on my AI controller or on my character or whatever is running around that has this queue of status effects. Basically, if this guy gets removed or he times out, it's going to say, okay, I have a next. So take this guy and have him point here. Right, and that's it. And then have my previous, so this guy's my next previous, have it point to null. So there's no previous before it anymore. And then he'll go ahead and destroy himself. So he takes care of itself. He calls his own destruction function and he's destructed. And then that's gone. And now this is pointed here and he has no hanging pointers and everything's kind of self-managed and working. And it's fine and dandy. The last one that we account for is the easiest of all of them, and that's if we have but one, which isn't showing up there. If we have but one, right, and he's going to be here. If this is the scenario where we only have one actor, and it's or one status effect, and it's destroying itself, then you really have no next, you have no previous, so it destroys itself, and there's nothing left to do. It just makes sure that this guy is now set to null. It's not expecting anything to be there, and it's gone. The space in memory is still technically there, just the pointer is now pointing at null. So it takes care of itself. So that's kind of the way that it's going to go about handling, removing various different things across different points inside of it. And the reason why this is going to happen is if you have a timer that's like 3 status effects that are put on basically at the same time. The first one could be for 5 seconds, the second one could be for 3 seconds, and the last one could be for a full minute. Right? In which case you're going to get the middle one falling out first, and then you're going to get the second one, then you're going to get the first one falling off, and then you're going to get the last one falling off. And that's kind of going to be the situation that we have to account for there, which is only 4 real checks to manage, which is not that much at all. In my code, I have it being like I don't even know how many lines of code it is. It's really small, but it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 lines of code for all of them together, which is really small. A lot of it's copy and paste, changing nulls and changing previous next, just swapping them around, as you could tell from the basic scenarios that we just kind of played out. But that's the whole idea behind it. It's a super simple thing that kind of manages itself, so they all know about each other. Well, they don't know about each other, but they know about their neighbors, and that's it. So that's how timeout effect works. Remove effect happens when the exorcist removes a buff. Now this is different than just calling timeout effect. You can't. Timeout effect was set up to be private for a reason, and that's because remove effect, you don't want it being called externally anyway, because of the timers that are set up, and it will try and call a function on something that's going to basically not exist if you destroy it. So remove effect, what it does is it looks for the first buff. So the idea behind it is that it's only going to remove buff effects, and that's because it's being used with the exorcist. So it's going to go through and it's going to look at, is this a buff or a debuff? And if it is a debuff, you don't want to remove it, so it'll look at the next effect. And if that one is a debuff, it'll look at the next one's next effect. And it'll just keep going down the chain until it finds one that's a buff. And then it'll call on that one, clear the timer, and then call timeout effect. Which means if you clear the timer, that timer is gone. It's not going to call functions anymore, and then you can go ahead and deal with the whole destroying it and linking everything together. So it just calls the same function. Because it's calling it within itself, it works just fine. Private is fine to use. And it acts as an entry point to prevent it from destroying itself. Then set affected actor, that's just setting this, very simple. Get the status sum. So basically what this does is it's going to look at your modification list and look at max HP. Or whatever status is assigned here. So I'm going to pass it a status name. So for this example, we're going to go with max HP. And it's going to look at the first status effect, grab all of the max HPs, and it's going to use recursion to do this. So basically it says, do I have a next? And if I have a next, look at its get status sum function. And it's going to do the same thing. So do I have a next? If I do, get its status sum function. So to bring up our boxes again, because they're a good little way of doing an example of this. Say all of these are HP. All right. Basically, we're going to have this guy here. We're going to go with something like this. So this one has 1 HP. This one could have 3. This one could have 5, and maybe 10. Right? So basically what happens is, this is my entry point for my character. All the time. It's always the very first one. Well, that was horrible. Right? So this is always the first one, and it has its nexts. Right? So the first thing that's accounted for is always the last one in the list. So if all of these are HPs, it's going to say, okay, do you have a next? Yes. Okay, look at it. Do you have a next? Yes. Do you have a next? Yes. Do you have a next? No. Okay, so if you don't have a next, give me all of the max HP values that you have. And if it has any, then it's going to return that value. If it doesn't, then it just continues on. So it says, okay, I have 10. All right, excellent. Now return 10. Here it says, okay, he just gave me 10. Do you have any HP? Yes, I have 5. Okay, we're going to add that together. We're at 15. Come back here. He just gave me 15. Do you have any? Yeah, okay, I have 3. All right, awesome. We're at 18 now. Let's go back here. Oh, yeah, they gave me 18. Awesome. 1. So we're at 1. All right, return the sum of them, and then it's back to your actor for whatever you called it for. And it's basically just going to return a float value, so you can use decimal points or whatever you want, and it'll work inside of here as well. So that's the way that the recursion is working. It's always going to the end and recursively coming back. And whatever one you go through here is going to go through the modification list and get only those values. So if you have one that's max HP and then plus defense, it's only going to get the max HP value for that. So you have to call 2 different functions over here for different values. It's kind of it's not necessarily the most efficient. It's not the least efficient. It's very situational. This has a lot of various different mechanics to it that you can basically say, I only want this. It's going to have a low overhead, but it does work. And you can use it for a bunch of different things as well. So that's the basically idea behind that. And then add to queue, pass it a new effect. Basically, it's set up so this is the kind of the external method where it doesn't always work, but it does sometimes. It's not something I'm completely happy with because I don't have a manager to kind of control how these things work. But basically what's going to happen is if you have no effects here, it's all blanked out. But you do have a pointer. So you have your base pointer. It's not pointing to anything. There's no effects so far. You're going to have to manually create your very first box. Right? So this will have to be your first one. You have to manually create it. Which is something that I'm not pleased with, but it works for now. So create your first one. Basically check, is this null? Yes, create one. If it's not null, you're going to have add to queue onto here, which automatically handles all the linking of where it's supposed to go. It checks, sets this one's the next and this previous over here, and it'll handle itself there. So this is the only exception that I really am not completely happy with, and that's, I think, is an acceptable amount of extra work to put in so far. Mostly because it does manage itself. There's no handling of deleting. The timers take care of themselves. You put a status effect on, it's a fire and forget. Put it on, don't worry about it ever again. It's going to handle itself. It's going to do its own cleaning up. And that's basically the effects that are kind of going on with our status effects, data structure. So let us know what you guys think. If you can find any ways of possibly optimizing this, I might want to, I should probably specify that each status effect this is basically virtual. It's not really because we need to be able to put it inside of here, but the idea behind it is this is a base class and you're going to have subclasses of it. And everything inside of this is basically going to be filled out in separate objects. And those separate objects are basically going to be just blueprints. And it's going to make it, and it goes there. And it all works, and it's fine and fun and awesome. So that's the way that it's going to work inside of Shadow Heroes. So if you guys have any ways that you think you can optimize it or any other ideas, let me know. We're always looking for different ways of improving and optimizing. Hopefully you can implement this kind of system as well. It doesn't have any container structure. It's kind of a floating linked list that helps manage itself, and it just kind of it's not that complicated of a data structure. It's specific to what we wanted it to do. So that's it. And if you guys have any questions, let me know, and I'll talk to you guys next time. Take care.